Welcome to clickmyproject.com.
Let us discuss about the automatic brain tumor tissue reduction based on hierarchical centroid sheet descriptor in T1 weighted MRI images. Let us discuss about the abstract of the product. So the brain tumor tissue reduction allows to localize a mass of normal cell in a slice of magnetic resonance. So that is a MR. So the segmentation in medical images were more helpful for the identification the disease portion in the images. So the pre-processing step is the first step of the segmentation process. The images were filtered using the median filter, which smoothens the overall image and makes that the intensity all over image is normalized. So the clustering process is employed for the images based on the k-mean process. The skull region is then removed from the images based on the k-mean processes. So the thresholding process employed for the segmentation of the tumorous portions in the input images. So the level set segmentation process employed for the segmentation of the tumorous portions in the input images. So finally, the performance analysis of the process is based on the performance metrics like true positive, false positive, true negative, false negative, accuracy, precision and recall. So the automation of this process is useful for post-processing of the extracted region of the interest, like of the humor segmentation. So in order to this is applied to the disseminated structure based on the pixel intensity, while the HCSD allowed to select only those having a specific shape. So the bounding box is then automatically placed to delineate the region in which tumor was found. So compared to the tumor deletion performed by an expert, a similarity measures of 91% of results of disease of coefficients. So the performance of the process is measured by using the accuracy, precision and recall of the process. Let us discuss about the flow diagram of the process. First of all, taking the input. So the input is will get the MRI data set. So that is a brain images we will get in the input, and then next step is a pre-processing. So in the pre-processing step we apply the median filter. So in the median filter is employed to smoothen the image and to filter unwanted pixels in the images. So the median filter passes through the image pixel by pixel, replacing each pixel with the median of neighboring pixels, thereby providing a normalized intensity so in the overall images. So the noises on the images were replaced in the above process. So this is a play of the median filter. And then the skull region captured along with the brain regions in the images were different intensity and in a large area. The skull region were identified to remove based on the morphological operations. So the morphological operations employed were open operation and close operations. So the metric dimension specificity the size of the structuring element, the pattern ones and zeros specify the space of structuring element. So the closing of an imaging by of the element is in the dilation followed by an erosion. So the opening of an image by a structuring element is an erosion followed by the dilation. So this is the process of median filter and also removing the sculling process. So the next process is a segmentation. So in the segmentation process there are two types of segmentation is applied. So one is a k-mean clustering, another one is a thresholding process. So the k-mean clustering, so in the k-means clustering process is employed based on the k-means process. So the regions in the image that are having similar intensity is clustered using the k-means algorithm. So in the fuzzy clustering event where the point has degree of belonging of clusters as a fuzzy logic rather than the belonging completely to just one clusters. So the points on each cluster may be clustered into lesser degree. So an overview and comparison of different fuzzy clustering algorithms is available. So and then the next one is thresholding. So in this thresholding process, the specificity threshold for the brain tumor portion is identified based on the identification of the maximum pixel of the input image. So the image pixels then were having maximum intensity were identified to be tumor portions. So the threshold value is adjusted such that the value of the threshold value is 30 pixel lower than the maximum pixel. So the image pixel that are greater than the threshold value were assigned to label 1 and others were giving the value 0. So the pixel value that we are giving the value 1 in the tumor portion in the images and other were normal images portion. So this is the thresholding process in the segmentation process. Finally, calculating the performance measure. So in the performance measures the true positive and negative, false positive and negative, and then finally calculate the accuracy, precision and recall. So the performance of the process is measured by measuring the accuracy of the process. So the accuracy is measured by comparing with the ground truth images. So true positive is correctly identified and the false is incorrectly identified, and then true negative is correctly rejected and the false negative is incorrectly rejected. So these are the overall flow diagram of the product. Let us discuss about the running procedure for the product. So click the main file and then run. So in this window we take the input image of the brain. So first of all select the input image and then it will open. So similarly all the images, the output results are displayed. Yeah, so the input image from getting by the data set, and then this is the pre-process image. On this image we apply the median filter. By using the median filter we get the pre-process image of the process, and then this image is a image label by cluster index. So that is a k-means listing we applied. So the k-means listing we applied the segmentation process. So the image label by the cluster index of the process, and then applying the HS3D, so the applying the thresholding of the process. So for the process of the brain image to get the segmentation of the process of the image, and then we getting the tumor reduction in the process. So in this image, skull removed image, so the brain image is taking the skull is removing by the image by using the pre-processing steps to remove the skull outer region of the process. And then in this image counter growing, so the tumor part of the process is detected by using the thresholding option of the process. And then levels segmented images are being calculated. The tumor part of the detection by the brain images, so the white portion is the tumor part of the process. Finally, these are the performance measures: true positive, true negative, false positive, false negative, and then accuracy, precision and recall. So these are the overall performance measure of the process. Finally, we recognize the tumor image is 5. So these are the overall running procedure of the product.
Thank you for listening this video.